Happy Friday. We are on to Quadratics Day 9. This is one of those days where we pull everything together that we've brought back or that we've done together for the past 9 days, 8 days of quadratics. And so we're kind of doing our first day of review in a sense. So we want to make sure that we know that there's a difference between all the different methods, but in the end, they do end up finding the same solutions. So we're going to look at the benefits of all of them. For those of you that are feeling strong about this, I would actually encourage you to go through this on your own first and then watch this video for the notes part. But I'm going to go through everything right now. So I'm going to follow the directions for each question. It says, using your graphing calculator, graph the parabola below, then find the zeros by looking at the graph. So the first graph I have is, now this says f of x. Now this just means it's the name of the function, but it's another way of saying y equals. So we're going to graph it. Oh, my window is different than what yours probably is right now. So it's not a bad idea to second plus 7 to your calculator, but I have back to my standard window. There's my parabola, okay? So I am asking you to graph it. And since I gave you a grid, that means I actually want you to graph it. Second graph, look at my table. Let's find that vertex. What's interesting about this one is that you'll see there is no middle number, but we know in a parabola that it does have the low end, so we need to be careful of that when we actually sketch it. I'll show you in a second how to also find that low point for those of you that are interested right now in doing that. So 0, -6, 6, 1, -6, 2, 0, -1, 0, and 3, 12 would be a little bit off, but just so we have a better idea of what the shape of it is. So in no time would this be a flat on the bottom. It actually goes curved just a little bit below it. So you'll still want to draw it that way. Okay, and if I look at my graph, if I actually wanted to know the point that's a low point, remember we can investigate in our calculator some of the features of graphs. So we press second trace, and there's some features that you might want to find. In our case, that parabola has a minimum, so if we press 3, and as long as we're to the left side of that vertex, you can press left a little bit more if you want to, but you don't have to, it's going to create a left wall, indicating where I want the calculator to look between the left wall and go to the right wall, and then guess. Once it doesn't have any more question marks and it tells you the word minimum, that's your minimum. So in fact, it's actually at 0.5, -6.75. So that would be the vertex. But in this case, I'm not really interested in the vertex, but I just wanted to share that information as well. So we have to find the zeros. The zeros are where it crosses the x-axis. So we just look, and it crosses at -1 and at 2. Okay? Second question, y equals 2x squared minus 4x minus 6. Take a look at it, make sure you've graphed everything correctly and it will work. There's my parabola. I can see right now where they cross. I think at -1 and 3, but let's just double check with that table. That's where we're looking for that special spot where the y is 0, and we were right, -1 and 3 are where they cross. But let's do -1, 3, 6, 4 is up at 10, and -2 is up at 10. So remember, parabola is always symmetric, and even though you're tempted to draw a V here, V is absolute value, so that's not the graph we're drawing. We're drawing a U, so make sure that it does curve. You do not want it to make it look like a V. And then we identified the roots are at -1 and 3. Okay, so now using your graphic calculator, look at the table to identify the zeros. Zeros, roots, x-intercepts, where y is 0, basically all the same. So in this case, it's not as obvious that it's quadratic, but when I were to distribute it, it would be a quadratic. So x minus 17, I'm just going to type in just as is, and x plus 2, there's my equation. Graph it, make note of that it is a quadratic, it is a parabola, and my interest right now is where the zeros are. Why can't I see the other one? because it's going down and then coming back up. So if you'd like to see it a little bit more, we can either do zoom, might as well do that one, zoom 3, or we could have changed our window. Okay, so basically, I'm asking you to look at the table anyways. So second graph, find where that y is 0. I see one of them, -2. And then I'm going to find that other one that was much higher than 10. When y is 0, x is 17. So just by looking at the table, I can identify where the zeros are, or the roots are. Okay, for part B, I'm asking you just to plot the equation just as is. No reason to distribute or do anything. The calculator will allow you to do it this way. Look at it to make sure that it's a parabola. May not have needed to have this window again, so if you want the back to the normal window, zoom 6 gives you that standard window. And then we're looking for where they cross. I think they're at -3 and 1, but we'll verify in our table because that's what we were asked to do. Look in our table. And it looks like one of the roots is -3 and the other one is 1. Okay, using your graphic calculator, find the zeros to the nearest 10th. So we'll look at y equals x squared minus 6x minus 19. There's my parabola. And oh, it's not crossing it at perfect integer on either side. So when I look at my table, I'm not going to be able to find, and you can notice that's where it changes from negative to positive, I'm not going to be able to identify when x is going up by 1s where y is 0, because I'm not going to be able to see it in my table. So this is a new function in here, a new feature that you'll need to know how to use your graphing calculator. We are going to use that second calc. Okay, so we're going to press second trace. Blue is the calc, that's what I'm looking for. I'm asking it to calculate one of these pieces of information. I showed you up top how to use the minimum. Right now what I'm going to be looking for are the zeros. I'm looking for 2, using second trace 2. Okay, now there are 2 zeros, so we need the calculator to focus in on only one spot at a time. So I'm going to focus on this one on the left first. I want to find my cursor so that it goes to the left side. So basically go to where you think the intersection is of the x-axis, where you think the root is, where you think the 0 is, and then press left a couple times. I know it's going up, but it's still going left. So press enter. Go back to where you think it is, and then press right a few times. That'll give you my left wall and my right wall for my calculator to focus in on, and my guess will be back where I think it is. So it looks to be that that point is at -2 point, nearest 10th, -2.3. Okay, so now we're going to do the second one. In order to find that one, we're going to do it again. Second trace, 2 is 0. I already found this one, so I want to find this one. So go over to approximately where it is. Use the cursor till you find it. And it looks to be like somewhere between 8 and 9. So it's about there. Once you go there, press left a few times so you're to the left of it. Go back to it. Press right a few times so you're to the right of it. Now you've given that window to the calculator to say, look in between here to tell me the 0. Go back to it to guess. So it's approximately 8.3 when I round it to the nearest 10th. Okay, so let's try another one. 3x squared plus 10x minus 8. Take a look at it, make sure it is a parabola and everything you put in is good. It's around -4 and it's around 0 to 1. So we're going to press second trace, find the 0. I'm going to do the left one first. I like doing the left one first because you know that you want to label them from least to greatest. So if I do the first one, that's going to be the one I first put in my squiggles, my brackets. So if I have approximately there, go left a few times, enter. Go back to it. Press right a few times, enter. Guess, back to it. So that one is at -4. That one we would have been able to find in the table. Oh, this is a good point to mention. See how this says -2 times 10 to the -12th? That is an E there. That's what that means. This is actually your calculator's way of approximating 0. So it actually is at 0. Sometimes there's some glitches in the calculator, but that really does mean 0. In fact, we were looking for the 0, so we know it's meant to be 0. So let's do this again. Second trace 2, and now we're going to find the one on the right. So we go closer to it, and then go left a few times, enter, go back to it, right a few times, enter, and then guess at 0.7 would be to the nearest tenth. So those are the 2 zeros for those. All right, so find the roots of the equation using the zero product rule. So we've done a few with our graphing calculator, and now we're going to go back to that zero product rule. The zero product rule tells me as long as it's equal to 0, either factor's got to be 0. So I already have it factored out for you. So one of those has to be 0. What will make the left one 0? -3. And what will make the right factor 0? 4. So zero product rule would tell me that those are my two answers, -3 and 4. For the zero product rule for this one, either factor's got to be 0. So I'm going to label them in least to greatest, so -4 and -2. Okay, you find the roots by using the zero product rule. That means I'm going to have to factor first. So I need to write out 2 factors that multiply to get that trinomial. So think about the ways we can multiply to get -14. Okay, so it's just 2 choices. I know that one will have to be positive, one will have to be negative because they multiply to get a negative. Since they add up to get a negative, the bigger one of these has to be negative. So it's either 1 minus 14 or 2 minus 7. That'll get me my -5. And 2 minus 7 would get me -5. So that's what I'm looking for. X plus 2 and X minus 7. Now I have it factored out. One of those factors has to be 0. So my answers are -2 and 7. Factoring out for the second one. The only way I could multiply to get 3 is 1 times 3. It's positive, and luckily, those add up to 4. So I have it factored out. One of the factors must be 0. That's what the zero product rule tells me. And to make the first factor 0, I would have to have x be a -1. And for the second factor to be 0, x would have to be -3. Okay, and for the next one, we're using the zero product rule again. I know that needs to be set equal to 0. Then you factor. So to multiply to get -3, 1 times 3. It's positive and negative. I need a +2. So let's do 3 minus 1. X plus 3, X minus 1. At any time, you're welcome to pause this video to look at some of the work. The answers are also posted on Google Classroom as well, with it already worked out. So those are my 2 roots for that one. Next one, zero product rule, you gotta have it equal to 0. So x squared plus 4x plus 3 equals 0. Guess what? We actually did this one. Yay! So my 2 solutions are -3 and -1. Just looked a little different because we had to move that -3 over to start. Okay, one more set of using that zero product rule. So the zero product rule meant you have to factor, you have to come up with 2 factors. Now this one is DOPS. So it's x plus 4 and x minus 4. So one of these factors has to be 0. Yes, you can graph these. Yes, you can use the square root method. But I am asking you to specifically use the zero product rule on this one. Again, on this one, this is another DOPS situation. So one of the factors has to be 0. What will make them 0? When x is 9 and when x is -9. So as you've noted, if there's two answers of the same, you could also write it as x equals plus or minus 4 and x equals plus or minus 9. Those would be acceptable as well. So either of the ones I have circled are good ways to write it. Okay, the next few, I'm asking you to use the square root method specifically. So to find the roots using the square root method. Square root of that method means that I have something squared on the left and numbers on the right, and you take the square root of both sides, and remember it's plus or minus that value. So x equals plus or minus 2. X equals a negative 2 and a positive 2. Square root of both sides, x equals plus or minus whatever I get for that square root of 32. And that 32 I'm going to break down, so wherever you want to write down the perfect squares to help you out. Okay, so I look at 32. 25 is not a factor. 16 is a factor. So it would be 16 times 2. So x either equals positive 4 radical 2 or negative 4 radical 2. Okay. Using square root method. If we use a square root method, we know that this would have worked for product, zero product rule, but I'm asking you to use the square root method. So I'm going to add the 9 over. Sorry. X equals plus or minus the square root of 9. So x equals plus or minus 3. Okay, for this one, we're going to have to move the 24 over since I'm asking you to do the square root method. Square root both sides, x equals plus or minus the square root of 24. That's not a perfect square, so I need to think about the factors. The largest factor of 24 that is a perfect square, and that is 4. So x equals plus or minus 2 radical 6. You can write them out separate, or you can leave them like that. Okay, now square root method for the next one. It is something that's squared, so now we're ready to take the square root of both sides. So it's just x minus 3 equals plus or minus the square root of 16. X minus 3 equals plus or minus 4. You have two equations here. You can add 3 and it'll be 3 plus 4, 3 minus 4, but I like writing them out separate. So x minus 3 equals 4, or x minus 3 equals negative 4. One solution is 7, and one solution is negative 1. Next one is set up already for square root method. So it's x plus 2 equals the square root of 18. And the square root of 18 can be broken down to 9 times 2. So that'll be 3 radical 2. So x plus 2 equals plus or minus 3 radical 2. X plus 2 equals positive 3 radical 2, or x plus 2 equals negative 3 radical 2. So you can also write this together if you want. So you can either write them separate or together. Either way is fine. And you don't see any of that. Hopefully you do now. I'll leave it there for a second. Sorry about that. Okay, and the last two questions. To use the square root method, can't have this number on the left-hand side. We're going to have to move it to the right. So x minus 3 squared equals 25. So x minus 3 equals plus or minus the square root of 25. X minus 3 equals plus or minus 5. X minus 3 equals positive 5, or x minus 3 equals negative 5. And then the last one, can't have it on the left-hand side if we're asking you to use the square root method. So it'll be x plus 2 squared equals 50. Now I can take the square root of both sides. But when I do the square root method, it's always plus or minus, breaking down 50 So x plus 2 equals plus or minus 5 radical 2. Put the negative 2 first. Or you can write them out separate, okay? All right, so this was a recap of everything we've been doing. We did some graphing questions, especially when they're nice answers. Then I showed you how to use a calculator if it wasn't a perfect answer where they could not find y to be 0 in the table. Then we did several with the zero product rule. This is a common way, also good practice of factoring. And then we did several with the square root method. Okay, so for tonight's homework, there's a spiral review. You want to subtract that from, so you take 5x squared and then subtract, just so you're aware of that. This is the way you should be doing it. Okay, subtracted from means in that order. You'll need to mark that out, write that out twice, distribute, and then combine like terms. But the homework, I want you to try with the directions. I know you have several choices here, but I want you to use your graphing calculator, use your graphing calculator, use your graphing calculator, so you're okay with that method. And then zero product rule, zero product rule, zero product rule, zero product rule, and these four are all with the square root method. I advise you to actually use those methods, looking back to what we did in the notes. Have a great day.